Hi, I'm Rich with insideHPC. We're here at ISC 2018 in Frankfurt, Germany, and today we're here to talk about the new IO500 list. And I have a couple of folks from the committee. We have Jay from Sandia and John Bent from DDN. Hey, thanks for having me. I'm real curious about this thing. What's it for?
We came at this starting in 2015 when what we really wanted to do was to create a long-term set of documentation that would allow us to understand what storage systems look like over time and what the performance characteristics are. And we needed some way to encourage people. So John came to us, Julian Kunkel at the University of Reading and I were working this in 2015, and John in 2016 said, we need an IO500 list. And I said, John, I got the perfect connection for this. So then the three of us got together and started working on this. So John recognized the one thing that we were missing to try to get participation, and that was to have some kind of competitive element that allowed people to justify to management why they would be allowed to spend all of this benchmark time on their machine. And because it gives them a public way to say, my storage system is better than your storage system, people have been encouraged and allowed by management to be able to run these benchmarks.
A universal kind of way to measure that would be fair, I would guess, right?
Yeah, absolutely. It needs to be fair, but it also needs to be representative, and it needs to be useful. And in fact, the real reason that I came to Jay to say we need this IO500 is because I was very frustrated that the only numbers that you see out there are the hero numbers that the vendors like to brag about, which do a disservice to the users because their applications never see anything like those hero numbers.
So why do we need a single number? Why that methodology?
Well, the single number gives us a way to abstractly say in a combined format that the overall system performance should be considered better than somebody else's. But what we really try to promote is all of the different components. So we have really 4 different things that we do. We have one set of tests that are hard for bandwidth writing. So we developed a series of configurations for the IOR benchmark that is essentially the worst case that we could come up with. And you have to run those. We did something similar for MD tests for metadata operations, and that gives us an IOPS number. And then because people will want to cheat and make their system look as good as possible, and plus we want to encourage people to tell us how to make their system the best way possible, we said, okay, we're going to give you the opportunity to do a pair of easy tests that essentially measure the same thing, and you're allowed to configure it any way you want, but the requirement is that you release all of the code and configuration information to achieve those results. And that way, even though your system may not be great on the hard tests, which we don't expect anybody's to be, you have those easy tests to say, this is what we're capable of if configured properly, and here's how you do it.
So the way that I like to describe this, Rich, is it creates a bounding box of expectation. So essentially we force everyone to report 4 numbers. The best that they can do for bandwidth, the best that they can do for metadata, but also the worst that they do for bandwidth and the worst that they do for metadata. And then 2 things happen. One, a user shows up on a machine, and basically every possible application should be somewhere in there, so they have a reasonable expectation. If they're outside of there, they need to figure out what's wrong. Otherwise, it's reasonable. Plus, what's even more important is it forces the vendors, everyone always tries to raise the ceiling. What's most important is to raise the floor. So we're really trying to encourage people to shrink that bounding box so that you get more predictable performance regardless of how your application does I/O, because scientists don't want to think about I/O. They want to think about physics and AI and autonomous driving.
Well, Jay, you were kind enough to put some slides together for us. Can we go through that?
Sure, that'd be great.
Okay.
So this slide deck was something that we presented at the Lustre Users Group back a month or 2 ago. And what we started off with was looking at what was the background for why we wanted to do this and how to include, what kind of things we wanted to include. And some of the things that we don't include currently are like data analytics tasks. We don't know of any good general benchmarks that we can use to incorporate them, but these are the kinds of things that we're looking to expand the IO500 list to include in the future. So that's one of our areas that we're trying to get community agreement on as to what are good representative benchmarks in that area. Cheaters, yeah. That was the thing about the hard and the easy. So since we know people are going to want to cheat, whether it's truly cheating or not, the easy tests give us a way to say, please cheat as much as you want, but you have to reveal what you did. It's kind of like a magician saying, I have to, in order for you to see this trick, I have to tell you how I did it. It's that kind of idea.
We spend a lot of time in the community talking about, do we need this and how do we do it? And the thing everyone would say is, no, people are going to game it. They're going to game it. And we said, yes, wouldn't that be wonderful? Because if somebody can figure out how to make these numbers better, guess what? They just figured out how to make storage better.
Yeah. And how to make all your applications consistently better. Yeah. So one of the key things that we looked at was, for the Department of Energy, we always specify 90% forward progress is required for our machines when we do a purchase. So that means you can spend 6 minutes per hour doing resilience-related tasks rather than computation.
Too much math, Rich.
Whoa, yeah, I was told there would be no math.
Right. Well, in looking at that, the easiest way that we saw to say, well, how much time can we really spend writing or reading, we said 5 minutes seems like a reasonable number, and that's easier than 6 minutes. So we just said, do each of these tasks in terms of the creation or the writing for 5 minutes, and then the reads run as long as they take. We did have one example currently where the one file system had a limit on the number of files that could be created in the directory, and because of that, it was not capable of running for the 5 minutes. So these are some of the things that we need to give feedback to the file system vendors and say, we got limitations here that are preventing things from working.
So John, let's switch over to you for your portion of this talk here.
Thanks, Rich. Yeah, what I'd like to do is show you what the list looks like now and who the second winner of the IO500 is.
Cool. Getting a scoop. Cool.
Getting the scoop right here. You heard it here first, Rich. Right. You would have heard it first in the BOF, but you didn't come. So the first list that we had 9 submissions, 5 file systems, BGFS, Data Warp, IME, Luster, and Spectrum Scale. You know, we really like this. It's a way for people to get more comparisons across the different file systems to figure out, in that particular bounding box, their application, maybe what file system makes the most sense for them. 8 different institutions. So in the second list, we did the first list at SC 17 and the second list at ISC 18. We grew to 14 submissions. We got a new file system. We got a submission from Panasas. We've been talking to the WECA people. They say that they're going to give us one at SC18. We'll have to report back and see what happened. We got a submission this year from Russia for the first time. A Luster system at the Joint Institute for Nuclear Research. And we got our first Panasas submission, as we said. So just taking a quick look at the top of the list. Last year, at the first list ever, the top 2 were the IME system at JCA HPC and the Data Warp system at KAUST. Both of them resubmitted, and both of them grew their scores. So let's see, the big reveal is coming, Rich. Okay. All right. So, Data Warp, they improved their bandwidth pretty significantly, and Data Warp did a nice job where they had a pretty big bounding box before, which I think is problematic because people don't know what their performance is going to be. They grew their top a little bit, and they grew their bottom a lot. So Data Warp did a really nice job closing the gap between easy and hard. IME grew both its easy and its hard, and it improved in both bandwidth and metadata. Actually, its gap, however, it's sort of interesting. IME for a long time has done a better job at preventing degradation, and now its upper bandwidth went up, and its lower bandwidth went up a little bit, but not that much. So it's interesting as a way of what would you prefer in a file system. You might think that this is strictly better because both the bottom and the top grew, but maybe it's worse because the amount of unpredictability also grew. So what happened with these 2 new submissions, and which ultimately was the winner of the second ever IO500? It was JCA HPC won yet again. Okay. They're at 137 gigaquads. Did you?
Yeah, we wanted to give it a unit name, but yeah, gigaquads. That's a good one.
As Jay was talking about before, we take a bunch of numbers, we have to compress them into one. It doesn't really have a good unit. Thank you very much to Rich. It will now be called gigaquads.
Terrific. Okay, so it goes to number 12 here. Yeah.
Oh, and so there are more submissions.
Yeah.
What we do is if somebody resubmits, In the main list, we only show them once. However, there's an expanded view where you can see the multiple lists, which is also interesting. You can look and see, why was it that JCA HPC had such a large jump? They improved their gigaquads by 37%, and it has to do with the version of the software that they were running.
So one other interesting thing on this is that some people have said we don't want to submit to the list because we only have a small machine and we can't compete with the big boys. And because of that, these are some of the things that we're looking at incorporating, at least in a test basis for SC18, is how about a small scale system saying, let's just pick a prime number like 11 nodes, what's the best you can do on 11 nodes? Or what's your per node performance to storage? And when we look at the numbers that way, and on the VI4IO website, which hosts the IO500 list, you can go through and cut the numbers all these different ways by putting in little math formulas. There's a lot of different things that you can do there. And that gives us a very different appearance as to what the real performance is. Because we know as you scale up, both it's harder to tune, but at the same time you also get a bit of a performance degradation.
Is there a significant time investment to run this? I mean, there's like WinPack can take days, right?
To do it fully tuned, yes, it takes time. But to actually just run it straight up, you download the repo, you run the script, and it will go. And since we have the stonewalling enabled, that means that it will run for the required 5 minutes for the write and the creation times, and then the reads will just run. So you get a base number out within an hour.
So I guess
And I'm pulling this up for you here, Rich. Yeah. It's really easy. You just git clone, you CD into the directory, you prepare it, you run it. And it's really that easy. It does take amount of time to run because you do the benchmarks have to run for 5 minutes each, and you do want to tune, but just to get that first number, we've tried to make it as simple as we possibly can.
Right, and since everybody has to reveal their configuration, you can then go look at the list and say which machine is most similar to mine, and you can start there for your tuning parameters. So there is a way to short circuit that tuning time as well.
Well, what's the call to action here, guys? We want more people to submit, obviously, right?
Absolutely.
Right. And since we are introducing the small system list, that gives a way for people with smaller systems that would still like to be able to contribute to our long-term archive of storage systems, a way to appear and not have to be compared against other sites. Because there is a fear, for example, that a vendor might use the list as is as marketing and say, look, my system is so much better than their system, when you're really not comparing two things fairly. So that's why we'll end up having a small system list and a large system list, but a combined archive so that we can look at things across time equally.
Hey guys, I really applaud your efforts here. It's great that we're bringing IO into this, and I'd love to see this become part of the student cluster thing, and because Henry's always complaining, well, they're not doing IO.
Please send my best to Henry. Please tell Henry I'm continuing to push the IO500. And absolutely, the call to action is submit. Let's get more numbers for the SC18. Come to the SC18 BOF. We'll see if WECA shows up then or not. And we'll build a really useful set of data for the entire community.
Two other bits of note. If you go to our IO500 mailing list, we are very responsive to any questions posed there, and we do keep them confidential. If you have any concerns that John is part of DDN, you can email just the other team members directly, and we will hide the results from him, so he will not get early warning. We do have a policy that there will be no reveals to any of our hiring organizations, but just in case you're extra paranoid, we will make sure that happens for you.
That's really nice. Well, great job, guys. Congratulations.
Thank you, Rich.
Thank you.